do that? How did you do that?
Broadcast as radio impulses into space. And all that they're being heard on every radio telescope on the entire
Okay, are we live? Okay. Thanks everybody for showing up. This is my first crack at being a moderator. We're having a flat Earth debate tonight with Bob the Science Guy, who is a flat Earth debunker, versus Stingray, who is playing the part of flat Earther. We're going to see how this goes and maybe make some headway tonight and figure out whether or not the Earth is flat. We're going to start out with 5-minute openers. Which one of you guys wants to go first?
All right, Bob can go first.
All right, Bob, you have 5 minutes.
Well, unfortunately, I've changed my mind. I think the world is flat. So you win, Stingray. Hey, thanks for having me, Cliff.
All right, shut it down.
All right. Well, my opening notes, I guess I get to say whatever I want to now, huh?
It's all yours.
As man gained awareness of his surroundings beyond his immediate need to assess food sources, dangers, and mates, his world was initially flat. As he began to move beyond his horizon and explore his domain, he began to notice things that triggered his curiosity. Why could he see objects from mountaintops that he could not see from the hills or the plains? As he traveled into the distance, why did the mountaintops appear before their bases, and why did the bases of the mountain appear as he got closer? Why did ships vanish hull first and sails last as they sailed away? Why did the constellations in the night sky revolve around a point? And how do stars help him navigate to lands he cannot see from the deck of his ship? Why did the seasons change? What is distance? What is time? At first, he proposed answers to these questions. Some felt that it was a deity. Others saw patterns that, once understood, allowed them to make predictions: when to plant, when to harvest, when the salmon would run. As time went on, we changed from our eyes to instruments. We gained an understanding of mathematics, and more patterns emerged. We confirmed our understandings by making predictions and then testing those predictions. If accurate, our understanding was sound. If falsified, we went back to the drawing board and developed new understandings based on the lessons we learned from our failures. We learned the understandings developed by our parents. We built on them, we improved them, and we left new questions for our children to answer. Our insights built on and corrected the works of those that came before us and continue long after we're gone. Not satisfied with simply understanding the world before our eyes, we used our new insight to expand the questions we previously hadn't thought to ask. What would happen if we rode a beam of light? That's a question that even the great thinkers of the past never considered. Only after we understood the nature of light would we think to ask the next question. And as we answered it, new unthought questions will arise. As our understanding advances, sometimes our abilities need to catch up. Uthos described his effect long before we were capable of directly testing it. Yet it was so worked out theoretically that when we did test it, it verified his understandings decades before. Likewise, we needed to await high-speed aircraft and satellites to fully test some of Einstein's thoughts on time. Yet his insight and work was confirmed and is in daily use within our GPS system. The key to science is the quest for insight in the world around us. We don't start with a narrative, we start with reality. We try to explain what we see, assuming our understandings are correct, and then try to use them to make predictions. Then we rigorously test those predictions in an attempt to falsify our understanding. Then we continue to make predictions and test them until we're comfortable with our understanding, and then we test them again. Along the way, we are revisited by those who seek not to understand the world around us. The constant need to better understand the world around us is replaced by those that prefer to put their trust in an unknown controller of their destiny. Those that view the understanding of nature as countering their long-held beliefs, a direct attack on a defining characteristic of them as a person. Likewise, those in science can be a force of ignorance as well, when they put attempts to expand their understanding as an attack on their reputation instead of an expansion of it. Attempts by elements of science to suppress a new point of view based on a previously answered question reflects on the weakness of the original answer rather than the weakness of the new one. As a species, we have progressed from having a basic awareness of our part in the universe to expanding the horizons to our current understanding and minute detail of natural processes we will never be able to personally experience. We make use of this understanding to build sextants and gyrocompasses to navigate our planet. We modify those same instruments to navigate between worlds and eventually between stars. We can predict eclipses for decades and even centuries in advance based on our understanding of orbital mechanics. We move from noting the weather to predicting it days in advance. We become the masters of our own destiny. And that's, my friend, what my view of science is.
Excellent, Bob. Great time management. You had about 10 seconds left. There was a couple of announcements that I forgot to make prior to. Everybody, please click the like button. And if you're in awe at the beautiful set that we have, that is thanks to Ilya Moon, who made that specially for this show tonight. And all super chats will be read. So each and every super chat that comes in will be read live. And I've got some more announcements, but I'll hold those for later. Stingray, you have 5 minutes, good sir.
Thank you very much, Cliff. And yeah, you're right. It's a globe. We're done. Thank you. In Bob's kind of start, but not really. You see, Bob did say a lot of things there, and I agree with a lot of them. The problem is in accumulated knowledge over time, we get to an advancement, an advanced state, a awareness of technology, and have this knowledge that cannot be held by a single individual. And unfortunately, throughout history, and I'm not going to name the numerous times this occurs, but that knowledge is regarded as power. Now, in the evolution of the human species, we've seen that coveting that power, that knowledge, has served a few people many, many times. Now, the issue we have with science is the same reason why, and you'll hear Bob tonight say we. He's on about the human race and the scientific achievements. But there's a little bit of a problem with that we. Can we build an aircraft carrier? Can we build an aircraft? Well, yes, but can an individual? Are you taking it on faith that someone has the skill and you trust in their skill set to be able to build an aircraft? The issue that we've got there is something could be amiss. There could be something astronomically strange about this process that's not disclosed in something as simple as building an aircraft. I'm not saying there is, but there could be, because one individual may not have the entire skill set to build an aircraft carrier or an aircraft or a jet engine. Because of that, this kind of process now of acquiring knowledge beyond a single individual's ability to understand makes it even more probable that we'll get people coveting knowledge for their own personal gains. Now, Bob, and I agree with him on this as well, the scientific community over the last 2,000 years has made incredible advancements, and that's absolutely fantastic. But there's an important thing about the scientific method in terms of falsification. And the globe Earth proponents always say, they always start with the argument, this supports our claim. And they always try and put the onus on the flat Earth proponent to prove, or how have you tried to falsify. But I've never heard any globe proponent say, well, I made this observation and this was the prediction, therefore globe, because they presupposed a globe to begin with. And in all fairness, I'm not going to argue against the fact that a lot of these observations look like we're on a planet. The issue is no one ever tries to falsify it, and no one comes up with alternative explanations. For this, you need an elite, special group of people that want to stand out from the rest. And yes, we are known as flat earthers, and we have some amazing skill sets in our community. We've got the likes of new and cutting edge experiments being done by Sleeping Warrior and Riley with his egg experiment. But more than that, the philosophical prowess that we have is amazing. We've got the likes of Dell or Behind the Imaginary Curve that absolutely came up with the breakthrough idea that gravity is not a pulling force at all, but it's a pushing force, because you can't have pull, everything is push. And I'll be going into that later because it's absolutely true. We've got the likes of Lemonbird that comes up with the coalescence of light and diffraction causing things to drop over the horizon. And again, I've got practical experiments later, or practical demonstrations later, that will absolutely prove that true. These are at the cutting edge of our current understanding, and we haven't had the time. We haven't had 2,000 years. We've only had 10 years, 5 years. So we are playing catch up, but some of the arguments that you'll see tonight, including a few arguments from that I've heard Bob make that I want to go into a little bit deeper in the discussion. You'll see how the presupposing of a globe taints almost every single thought of every globe proponent. They're looking for confirmation bias. They don't think they are, and they blame flat earthers, but they actually are. And I'll yield the rest of my time. Cheers.
Excellent, Stingray. You have my interest piqued. So now we're going to go into 15-minute presentations. I'm assuming Bob will go first. Is that okay with you, Bob?
I'm here by your command, sir.
Well, I think we were both the same rank in the military, so I'm not your sir, but yeah, go ahead. Unless Stingray would like to go first, then go ahead.
Any preference from you, my friend?
I'm fine, sir. You go right ahead.
All right. Well, I have 5 basic conditions that I use when I deal with the flat earth. And one of which is you can't tell me that I can't measure curvature or rotation because I've personally done it. Now, to address your specific point that we presume that the earth is a sphere or globe shaped, I would disagree with that. One of the first flat earth experiments that I did with Harry, Blue Marble Science. He and I are on approximately the same line of longitude, and we are about 500 miles apart. And on the solar equinox, a year ago March, he and I both measured the angle of the shadows. And our idea was that on a flat plane, we would be able to triangulate the distance to the sun, knowing our distance from each other and to the equator. The unfortunate thing is that did not match our expectation that the earth was flat. And as a result of that, we had to abandon or falsify that particular assertion, and we attempted then to make a curved surface to the earth to see if it would match, and lo and behold, it did. Now, one of the things that you have to do in scientific method is that you have to come up with some sort of an explanation as to what you're seeing, what's going on here. And then you need to assume that that explanation is correct. And then you need to make a prediction based on that explanation. Then you test that prediction for reality. May I share my screen briefly? That was your cue to say something, Cliff.
Yeah. Bull's got it.
All right. So One of the things that I wanted to do was have a look at this picture from one of your flat Earth scientists, Jay Tolan. And Jay Tolan did an observation of Mount San Jacinto from Malibu, California, which was an approximate distance of 123 miles, or for those of you that didn't go to the moon, 195 kilometers. And what we did was I basically made a prediction as to what part of that mountain we could see if the Earth was flat. And I found that I was missing very large quantities of the mountain. So then I took what is assumed to be the accepted value of the radius of the Earth, and I calculated how much of that mountain should be visible if that radius was correct. And what you see on the screen right now is actually that photograph. So this is Jay Tolan Media One's photograph here, and this red cross that you can see is where I predicted the mountain would be visible based on using the radius value of the Earth that is accepted. And as you can see, the predicted value matched the actual value very closely. And this is the strength of science, and that is that we have predictive value to science. Now, is it possible on the flat Earth to be able to predict how much of that mountain would be visible due to ether band, compression, the Raleigh criterion, and any of the other excuses that we have heard? It's very nice to be able to put out a reason that something happens. But unless you can use that reason to make a prediction and then test that prediction against reality, it's just a story. So another example of that would be being able to look at evidence and see it for what it is. For example, these are the phases of Venus. Now, if the Earth is flat and covered with some sort of a celestial dome, where is Venus? Why is it when Venus is crescent-shaped, such as this, it's 6 times the size of the fully lit Venus? Now, while this is perfectly explained on the heliocentric model, this has yet to be explained on a flat Earth model. And no predictions, obviously, can come if you don't have even a basic rough model to try and explain what you're witnessing, your observed phenomena. And the cases go on and on. How does a gyrocompass work on a flat Earth, a non-rotating flat Earth? We know exactly how it works on a rotating Earth. How does the Otvos effect work on a flat, non-motion, immovable Earth? We know exactly how it works on a rotating Earth, and I've personally measured it. You know, to address your point directly, Stingray, you say that knowledge can be hoarded, and I absolutely agree with you. Knowledge is always power. The ability to make predictions that come true is wizardry. And the ability to do that gives you power over others. However, I have to go back to the words of Steve Jobs, and he suggested that you look around you. Everything that you see around you, every piece of technology, the paint on the walls, the construction of your home, everything that you see around you was conceived, designed, and built by somebody no smarter than you are. And quite frankly, you have the ability to personally look at many of these things and come to your own conclusions for them. The difference between science and the flat Earth is that science looks. The flat Earth raises objections and says, what if? Well, it could be CGI. Well, yes, it could be CGI, but you still have to show that it is CGI. There's a difference between saying we can do something and we did do something. So that's basically what I have for this, and I'll turn it back over to the moderator.
Thank you very much for that, Bob. Before we get going with Stingray, I've got a few super chats that I want to read out. From Tarek Asherex, I hope I'm saying that right. He says, I like stupid. Thank you for your service. And I like bringing you stupid. So thank you for your $5, sir. Next, the harsh truth. If the earth is flat, why can't I see New York City from LA with a moderately powered telescope? That's a question for Stingray. And next for 1999, Pops says, keep calling out those frauditors. And I will keep calling out those frauditors. Thank you for your 1999, sir. Stingray, your 15 minutes begins as soon as Bull gets the clock up. And go ahead, sir.
Right, so yes, I'm going to just set my little camera up so that I get a nice feed. But just really quickly, I want to address a few things that Bob said about knowledge specifically. And he mentioned a very, not a mundane, not a trivial thing, but let's say plastering or painting. So what we see from Globers a lot, although they seem to point it out more with flat earthers, is a false equivalence. Saying that the knowledge to paint a wall is similar to most of the scientific disciplines, such as understanding of TEM theory in understanding light within the physics realm, or even quantum physics. These are things that this is knowledge that most of the time takes teams of individuals with different skill sets. This cannot be held by an individual, and since this is the case, there is always that opportunity for abuse. Now, I'm just going to present something. Here we go. Present a window. So I got a lovely new camera, and this lovely new camera is pretty fascinating. Am I up, Dave? Can you see my screen?
Yes.
Yes, you are.
Awesome. So I have actually got a little ball here, and I've got a lens cap in front. Now, there's a very nice effect when we get to very acute angles. Now, what I have an ability to do with this camera is zoom in a little bit. And in fact, let's just make this a little bit brighter. There we go. And I can zoom in a little bit. Now, we can see the base. And all I'm doing here is I'm altering the focal distance of the camera to show an effect. Now, what we have, and I might just have to throw some light on this, what we have here is we have a surface. And can you see what's happening to that ball? I'm not moving the camera up and down. It's actually fixed on a tripod, and I can show you this later. But what I can do by altering the focus slightly and getting an effect that, hang about, this is raising, we're seeing compression, and it's kind of dipping down below the surface. You can see this. And this is center lens as well. So we can see, and if you imagine this distance from here, which is where my finger is, to here is about, to the ball is about 15 centimeters. That's it. And I can get this small effect. Imagine what this would be like scaled up. Imagine this lens cap here being the apparent horizon. So if I come all the way to, where are we? There we go. And can you see how much of the ball it's covering? Except when we go back, we can see that actually it's not, and we can see that it is. And we can see this down over the horizon effect. So that's one of the things I want to point out, and shout out to Lemon for being utterly correct with the statement that diffraction and lens light coalescence is potentially responsible for ships going over the horizon. Now, the next thing that I want to present, because I've not seen this and it does need to be put out there, is a flat Earth model. Now, we've always had issues, and it doesn't matter what flat earther, an honest flat earther will actually say, yeah, we've got an issue with this sun and the moon. We've got real issues with them, because on a flat Earth model, we can see here, the sun goes around. Yep, got a bit of an issue there, because anybody with common sense will tell you that this doesn't create a sunrise nor a sunset. However, what we don't understand here, quite literally, is what this light source is. Globers claim to know. we actually are under the opinion that you don't know, and you don't know what's happening to the light. So now what I'm going to do is I'm going to show you just quite simply what would happen if we had a toroidal field following the sun, because it was a massive source of energy. Now, this toroidal field is interesting because it would bend light. But the interesting thing about this is, from a side-on view, it would bend light round so that to an observer here, they would be looking at a sunset. Here, on the right, it would be totally dark unless you went up, and you'd be able to see the sun at a lower elevation. So this toroidal field adequately explains the light paths of a sun and a sunset on a flat, beautiful spinning disk. And then the other points that I want to bring up really quickly is, let's have a look. So Dell is another absolutely amazing philosopher that we have. Now, he came up with something quite amazing, and it's in direct contradiction to the heliocentric globe understanding of gravity. Now, the unfortunate thing is a flat earther should not argue that things fall. That's absolutely wrong. Actually saying that it's mass dependent or matter dependent as well, that's a fair thing to assume, but it's not a pulling force. It's far from a pulling force. It's actually a pushing force. Now, we call it ether, or a fabric, which we call ether, that exists everywhere. And to some extent, Einstein calls it space-time. But imagine a fabric that emits pushytrons, not gravitons, pushytrons from every single direction. And when these pushytrons hit masses, they slow down and they exert energy. Now, what you actually end up with at the end is a shade of objects that are cast by objects of little or no force, which you incorrectly perceive as attraction, but it's not. It's lack of push, and it's the shade generated by all the pushytrons hitting this side and all the pushytrons hitting this side, and the shade between causes the attraction. Even your Cavendish was wrong. And these are just some of the ideas as flat earthers that we can embrace and test. We postulate these things and can put them forward, and they stand up to scrutiny. And I'll yield the rest of my time. Thank you.
Thank you, Stingray, and thank you for pushytrons. I'm going to add that to my lexicon. Okay, now we're going into the 30-minute open discussion time, so you guys can just kick your ideas back and forth and have at it.
Can I go first, Bob? I've got a question for you. I've really got a question for you.
Please, go right ahead.
I've heard you say on Jose's show that you've seen curvature. Can you explain what you mean by that, please?
Oh, of course. Well, I've already given an example of curvature right here. Let me go ahead and show that to you again.
But seeing with your own eyes, is that fair to say? Not kind of inferred, but seen with your own eyes. That's what I mean.
Yeah, I've got some right here.
All right, cool.
There you go. There's curvature right there. Now, the reason that is curvature, and the reason I see curvature from an aircraft, for example, is the horizon is dipping down and falling away from me, and I can't see things beyond it. I'm not going to tell you that I could see side-to-side curvature, although I've seen evidence of that as well. The main curvature that we all see, you included, is the curvature going away from us. And that curvature, it perfectly explains this photograph of this mountain. The curvature perfectly explains how far I should be able to see from an aircraft and how far I can identify landmarks. So yes, indeed, I can see curvature going away from me.
Nice.
Now,
Okay,
here's
so I've got a follow-up question with this, Bob, just before we
Please.
move on, if you don't mind. So, okay, so we have a thing that we find we're faced with every single time, and the globe earthers bring it up quite a lot, and it's called refraction. Can you just give me a basic rundown of what refraction is, please?
Certainly, refraction is light passing through air of different densities. And in general, what will happen is light will refract downward towards the thicker density, or the more dense layer. So when you see an object that's on the horizon, the light from that object is being bent downward to you, and it actually, and the object itself appears to be higher on the horizon than it actually is. And that predominantly affects the lower 10 degrees of the sky just above the horizon. Now, if you look at something like the Eratosthenes observation that Blue Marble Science and I did, we were dealing with light that was coming downward from directly above us, with just a few degrees off the direct 90 degrees mark. And quite frankly, refraction in that situation is essentially zero. Now, I have actually done a little bit of work with Al Biruni, and we've got a couple of different observations. So, for example, refraction becomes very significant the closer you are to, say, the level of the sea. If you do an observation from the seashore at 1 or 2 feet off of the surface, you're going to have a significant amount of refraction because you're going through those very bottom layers. As you get a little bit higher, say up to, say, 72 feet, as the main surveyor did, and do the Al Biruni work, the refraction will give you an error in your radius of the Earth by a little less than 5%. Whereas if you go up to 45,000 feet and measure the drop to the horizon, the error in the measured radius versus the actual accepted radius is less than 1/3%. And by the time you get up to the International Space Station, refraction is essentially negligible. So there is an error due to refraction in measurements such as that, but you have to be able to actually calculate how much of an error there is and then decide whether or not that's a significant amount of error.
So what I got from that, Bob, is light bends towards a denser medium. Okay, that's good. So I've seen a lot of these hot air balloons, these weather balloons, and I've seen them when they launch and go up, which, by the way, don't show curvature, but when they're going up, they actually have loads of sensor readouts and things like that, and they have temperature on there. Can you tell me what happens to that temperature as it reading as it actually goes up in altitude?
What does the temperature reading on a weather balloon do?
Yeah. As it's rising up in altitude, what would you expect the temperature readout to do as it rises in altitude?
I would expect the temperature readout to drop approximately 1 degree centigrade for every 1,000 feet. And it will come to a point where it'll actually go up maybe 1 degree and then start going down again in the thermosphere. Okay,
cool. So I've got a question. Is hot air denser than cold air?
It's less dense than cold air.
Okay, cool. So cold air is so hot air is less dense, cold air is denser, and as we rise up, the temperature drops, except for that at the top end of the thermosphere, like you said. That's brilliant. So in what you've just previously said, you said light bends towards the denser medium, so it bends towards the cold air, obviously, which would make light bend upwards, not down. And if light's bending upwards predominantly due to that temperature gradient, would that not present a flat surface as being somewhat like the planet that you purport we live on?
Well, unfortunately, the temperature is not the only factor involved, because as you go up, yes, the temperature drops down, but so does the density of the atmosphere because the air is thinner. So the densest air in our atmosphere is down by the surface.
But you would say that the cold air is obviously denser and that light bends towards the denser medium. Are you saying that we get a perfect gradient in the opposite way to temperature then?
I wouldn't say it's perfect. I'd have to actually compare the two. We have a temperature gradient and we have a pressure gradient.
Is there any way, sorry, Bob, really quick question. Really sorry to interrupt you. I really, really am. But is there any way where we see in basic observations where light does bend up and we can actually see that effect and identify it?
Well, let's see. There is a phenomenon called sinking, where objects appear to be lower than they actually are, and you would see that in a temperature inversion. I would think that you would see that over, for example, very warm water with cold air on it. So the layers of the air immediately above the surface would actually be reversed. The lower layers would be warmer and less dense than layers just above them, but we're talking a matter of feet here. So
is this something that you've got out and personally verified, Bob? Or is it just the rhetoric of scientific consensus?
Well, unfortunately, there is no requirement in science for me to personally verify anything.
So it's faith then, still faith.
Part of the tenet of science is that you build on the work done before you. So
how do you verify? Wait, just really quickly, Bob. How do you verify if that's right? Because if that was the case, wouldn't I still be sticking leeches to myself to cure some ailments if all we did was build upon previous knowledge?
Well, it's funny that you mentioned leeches, because the idea behind leeches actually was to reduce venous congestion. And although they fell out of favor when we stopped bleeding people, they are in favor for things such as microsurgery right now to help prevent venous congestion in reattached fingers. So they'll put a leech on the finger to keep the pressure down. But they're medical leeches, so they're okay.
Okay, trained medical leeches. Get it. I love this science stuff. So
trained medical leeches, yes.
So a very interesting takeaway there is you said, yes, light can bend up, and we call it sinking in the magnitude classification of refraction, and that that happens with temperature inversion, and we know that temperature is indeed inverted. So how then would we verify that light is bending down across, for instance, your J. Tolan's Mount Cinto? How can we verify that light is actually bending down and not up? Because you've got to admit, if it's flat and light's bending up, it looks exactly like that.
Well, unfortunately, you're missing a great deal of the mountain. And no amount of light bending is going to make that 6,000 feet of that mountain that is below the surface appear above it. Second of all,
just really quickly, Bob. Sorry, I really do apologize in interrupting you, but I don't. When on the flat, if it was flat, and the light from the bottom of that mountain and from that whole view predominantly bends upwards and not down, is it your assertion that on a flat Earth, with light predominantly bending upwards due to the temperature inversion that we see every day, almost everywhere, if light's bending up, would it not present as what you call the curve of the Earth?
No, because it wouldn't bend that much. Second of all, you can actually do some measurements. You can use that. You can use your toroidal fields and your positrons. These are all very valid hypotheses. They're very valid hypotheses, all right? Now, but that's only part of the scientific method. Now you're going to have to make a prediction as to how much of that mountain, excuse me, let me rephrase that. You would have to predict how much of a temperature inversion would cause that amount of the mountain to be below the surface. And then you would have to go out and measure the temperature of the ocean and the temperature of the air. And both those measurements are easily available.
So I've got a question on that as well then.
You can test your prediction that that's due to a temperature inversion because the water is much warmer than the air is. And then you can test to see how much of a difference would be required to bend light that amount.
Okay,
it could
cool.
be through experimentation and through the documentation from weather records.
Nice. So what I could do there quite literally is, so let's say make a prediction. I can say that standard temperature gradients cause light to arc upwards and thus present the world as being a sphere, as in it's going down, which would be the optical reality of that. And then I can make a prediction of, well, those temperatures sometimes change and they're not exact, which then would move that horizon backwards and forwards, further away and closer, and hide more and less. Is that what you're saying? That kind of prediction, yeah?
Well, that absolutely could. And you would have a range that would be acceptable. So for example, say your ocean temperature varied by 3 degrees. Okay? That could vary the distance, and your air was held stable. That could vary the distance to your horizon based on that 3-degree temperature change. Then you could also do the same thing with the air temperature. What would a 10-degree change in the temperature of the air do? And then you could get a range of where that horizon should be. And then you could test that. And you would test it by finding an object such as Mount San Jacinto and measuring landmarks on that mountain that would tell you exactly how much was there and see whether or not your predictions turned out to be correct. And that's a valid form of science.
Is your, I take it you've done these predictions for, you said you did the math on that mountain, and you predicted, and I take it was very close, correct, for the curvature of the Earth, or the supposed curvature of the Earth?
Yes, indeed it was. I've got that red cross exactly where I predicted.
Okay, can you tell me what
could be? And as you can see, the horizon is very close. Now, the fact that it's off a little bit is due to 2 factors. One is difficulty in drawing the cross line on the irregular terrain. And the second is I didn't take into account minor variations in water and air temperature giving slight differences between standard refraction. So for example, that cross looks like it's a little bit high compared, well, let me rephrase that. The horizon looks a little bit lower than the cross would suggest. Now that would mean that we had a little bit more refraction than standard, and as a result, the mountain appeared to be slightly higher. But again, when you're dealing with 6,000 feet of missing mountain, you're dealing with maybe 100 feet of variation there. So it's well within an acceptable parameter.
Okay, how did you work out that acceptable parameter? Near enough matches the globe predictions would be acceptable? Is that the way that it's done?
I would say that the best way to do that is you would look at the accuracy and precision of your measuring equipment, your marking equipment, and see what would be, if you do this 1,000 times, what would the standard variation be? So if you want to do it formally, what you would have to do is measure this multiple times and see what the variation is, and then get a standard deviation from that.
Right, to get an accurate result. Brilliant. And how many times did you do it again, Bob?
I've just done the one.
Oh, that's a brilliant broad spectrum approach to the method that you just said then, right?
Well, I'm not the only one that's ever done this, but it worked on this one. I made the prediction, and there it is.
But the issue
That's
that I've
an
got with
argument
this,
in my favor. It's not conclusive, but it's an argument in my favor.
well, it's also an argument for consistent and linear temperature inversion causing the uniform upward bending of light to present a flat Earth as a curve as well. And I'm saying, quite simply, how did you rule that out? How did you attempt to falsify your own predictions or understanding?
I used my understanding to make a prediction. I marked what that prediction would be, and then I compared it against reality. It was a test of a prediction.
Okay, but again, if I have an inverse effect due to upward bending light, would that not also present optically exactly how you've just shown it?
Well, we could demonstrate that one way or the other. We could simply look at the temperature of the air in the sea on that particular day we could do a little bit of research, and that could be an experiment on your part to try and invalidate my results. And that's what science is about. Every scientist expects to have their results questioned and other people test them. So there's a test that you can do. You're more than welcome to go ahead and check the weather conditions on that particular day and demonstrate how that could be upward bending of light.
Because I'm just curious. Well, not curious, but concerned that most of the globe Earth proponents, again, it just seems, and I'm really sorry for saying this, but it does seem like confirmation bias. This is my prediction for a globe, and this is what I see, and that matches reality. But if that reality can be created by another effect, you never explore that, which is fine. But some people would say that's more religious than scientific, because we're in science, obviously, we should always be looking to try and invalidate something or gain a better understanding of it, or maybe even try alternatives. The problem that I've got is it looks like from the globe side that you find this one thing which undoubtedly works. It really does. But then you don't try anything else because it fits that explanation. And that's as bad as sometimes what people call flat earthers is only having one cause to an effect and not two. It's the same way of saying, well, 2 + 2 = 4. Brilliant. So I don't need to consider 1 + 3. And I fundamentally disagree with that as a flat earther. But thank you very much for your time, Bob. I appreciate that. And I'm sure you've got questions about pushytrons.
Honestly, I don't. And the reason that I don't have questions about pushytrons is this. Same reason I don't have a question about a toroidal field. You've come up with a possible hypothesis here. And that's what science is about. You have a hypothesis that you think may explain something that we see. Now you have to make a prediction based on that, and you have to actually test that prediction. So, quite frankly, more power to you, my friend. Now go out, make a prediction, and test it, and then let's review your data together.
The issue is, Bob, this has already been tested. Cavendish did it, and he saw what he perceived as an attracting force, and he even measured what he called the mass of the Earth via this. But the issue with that is that matches the behavior of pushytrons exactly, because we're on about occlusion and shade of mass, which you could interpret again, and this is another failing of the globe Earth. You take one thing and it fits, and there's no doubt it fits. Mass attracting mass, that fits. But also does a fabric pushing out pushytrons in every single direction and hitting solid matter, and it's the shade generated by those pushytrons on that matter that impart a force that pushes it, much like having the two balls in the example that I showed being pushed together. You see them as being pulled, but it's not. It's the shade of the pushytron force that's being cast by both of those, the balls and the matter that makes them up. So again, it's the issue that I've got is, again, you all have this one indication of something being true, and no doubt it looks true, but you don't explore alternatives that can adequately explain 9.8 meters per second accelerating force.
And again, you are welcome to make that case. And what you should do is make a prediction and demonstrate that a pushytron would push an object downward at 9.8 meters per second squared. Now, the other thing that you have to do is you have to be able to look at our understanding of gravity in general. So, for example, in what direction would a pushytron bend light?
In the direction that it is traveling.
And if you have a large massive object, in what direction would that bend the light?
The mass is nothing more than casting shade. So it would the light would actually bend towards the mass because there are less pushytrons coming through from the opposing side to make the light travel straight.
Okay, that would be a good thing to test. How would you test that?
we could have a look at. I actually don't know. I haven't thought that far yet. This is all very new. Like I say, you guys have had thousands of years to think about this. We've been going like 10, maybe 5.
Okay, cool. So, so here's where I would say science has one on you. You go ahead and develop that. You develop that test, and we'll see the results of your test. You can predict something, and then you can test that prediction, but you'd have to figure out a way to test it. So that would be a very valid experiment for you to do.
Oh,
and
yeah,
I
absolutely, Bob.
the
But
results of it with you.
the issue of testing that is you'll just say it's gravity because, for all intents and purposes, we are looking at the same effect. It's just you say, or with Einstein's general relativity, it's the bending of space-time or Newton's mass-dependent attraction. But there is no difference between the apparent effect of those two versus omnipresent, omnidirectional emitting positrons from the ether fabric.
Okay, good. Well, I think you've got a great point with that. But there are two questions that you have to ask yourself. If Einstein provides an adequate predicting power, what is the benefit of going to your hypothesis and excluding that one? How does your hypothesis explain it better? And second of all, part of science is peer review. And the purpose of peer review is not to evaluate the quality of your idea, but as to whether or not it's to evaluate whether your test will give a yes or a no answer. So again, you will have to develop a test that would give you a definitive answer, or at least lean you one way or the other, that would differentiate positrons from space-time. So that's your task. You've got to find that test that will give you an answer one way or the other. Now, by the way, you asked something about a single example of a mountain or a curve of the earth obscuring part of a mountain. Well, we can actually use that exact same curve of the earth to make other predictions, such as this one right here. Knowing a known distance between the observer, a known height, using the exact same curve of the earth, we can predict exactly what we will see in this photograph. And that's the beauty and the power of being able to have a good model that you can use to make predictions. And again, how would you explain this on a flat earth? How would you define how much of those buildings should be missing? So how can I figure that out and draw a red cross on a picture of Chicago and have it match this, as I did with Mount San Jacinto?
Really simple, Bob. Light predominantly bends upwards due to the temperature that we just previously discussed, which would actually present like you just shown.
Except the temperature of Lake Michigan is considerably colder than the air. So your temperature inversion idea is not valid in this particular case. But again, the point is you have a valid idea, and that is you can have a reverse temperature inversion. Can you predict how much of that building will be visible based on your understanding of it?
Quite possibly we could, yes. It will take a little bit of time, but I'm guessing that, you know, some of our greatest minds are working on this right now, like the Oakleys and the Rileys. So yes, give us time and we will.
Well, when they do it, we can measure an air temperature, we can measure a water temperature, we can get their prediction, and I'll take the picture and we'll see if it matches. How's that sound? Because I live not far from where this picture was taken.
That sounds awesome, Bob. That really does.
Okay, so when you can give me, say, some sort of a chart that would allow me to predict how much of that building will be missing, I'll go out, read your chart, and take the picture, and then I'll let you compare it to your predicted value versus what actually occurred. I don't mind going in the field and helping you out with it.
I've got a question for you, Bob. Can you tell me the difference between inferring something and measuring it empirically?
Inferring something and measuring it.
Yeah.
Well,
So we have a lot of, in all of this, we have a lot of inference. We join two things together that seemingly match, and we come up with a conclusion. Whereas an empirical measurement, can you tell me the empirical measurements that have been done for the curvature of the Earth, for example?
well, let's see. Surveys are based on empirical measurements, are they not?
So someone's actually, can you explain what someone's doing in a survey task, please?
No, I'm not an expert on that. I have an understanding of survey technique.
All right. So
Yeah,
this is the same thing of what I was saying about the method that people can't really. We don't have the knowledge, and you're just saying you take that on faith, which I get. I absolutely get that you take that on faith, Bob, and I understand it because I've spoken to a lot of religious people as well. But do you know anybody that's personally, empirically measured the curvature of the Earth?
Yes.
And who's that?
Jesse Kozlowski's one.
And how did he measure it, Bob?
He used survey techniques with it, which is what I was getting ready to tell you before you interrupted me.
Oh, I'm sorry.
One way that you can do that, the way a survey works when you're looking at curvature, is you take a staff with gradations on it of a known height.
Mm-hmm.
And then you can take a theodolite, which you level to the point where the theodolite is mounted, and you can actually read the height that's at the same level on the staff. Another variation would be, what's that? The Bedford level experiment. And I'm thinking about actually doing a Bedford level over 3 miles at Lake Otsego here in Michigan, which is a north-south lake. So you can actually.
I actually believe that a really annoying guy on your side called the Rumpus is actually doing the Bedford level experiment in my country as well, which is a bit freaky. But you do realize that on the first attempt of that experiment that it showed flat, right?
And you also realize that that has been easily explained, and when that explanation was used to minimize the error on it, the curvature came out. And so that error had to do with refraction very near the surface of the water. So
right. Okay.
When they revised it to put it 14 feet above the surface of the water and get out of that refractive zone, remember I told you it was only very near the surface of the Earth. They got those things up 14 feet, and there was a difference between them, and there was demonstration of curvature.
Right. Okay. So refraction is the answer. So it measured optically flat, and you didn't like that. So then you introduce this refraction, which bends light downwards towards the denser medium, which isn't always downwards to match the expected curvature on the globe. That's all I just heard there, Bob.
Well, unfortunately, you didn't hear enough of it then, Stingray. Refraction is a known effect, and it is measurable not just on the Earth. It's measurable by using, for example, a prism. You can use a triangular prism and refract light, and you can demonstrate it, and it has nothing to do with a surface.
Oh no, I absolutely understand refraction, Bob. I promise you, I understand it. I understand the prism. I understand the different wavelength separations. I actually understand the quantum effect of a photon meeting an electron field, which is the actual mechanics behind refraction. I'm arguing that predominantly it goes up, and when you find a result where it sometimes goes straight, such as in the first Bedford level experiment, that it must be wrong, because I'm presupposing a globe. So therefore, I'm going to add tolerances to make it so that the globe is acceptable as an answer.
Okay, let's finish this thought process. Our time is up for this section. We'll still be able to talk about that as we get audience questions, but go ahead and just finish your thought process on that for a minute.
Okay, our tolerances are not based on an outcome. Our tolerances are based on measurement error and experimentation that demonstrates that this occurs at the water level, but it occurs considerably less 14 feet above the water level. So one of the things that you have to do when you're making measurements is that you've got to make sure that you are looking at possible sources of error and eliminating them. So for example, with your lens camp experiment, one of the things that I noticed was that the lens cap was considerably out of focus and you were changing the focal length. That was causing a fuzziness and an expansion of the lens cap. When the lens cap
just 2 seconds, Bob. I'm sorry to correct you, I really am, but I wasn't changing the focal length. I was changing the position of the focal distance, which is a focal plane. The focal length was always 28 millimeters, for your information.
Okay, good. All right, but you were changing the focus, and
yes,
that caused the difference. That was Now, can that effect be demonstrated over something that's not directly over a surface? Can that be demonstrated straight up, for example? So if you can demonstrate that straight up, it's effect that's independent of the surface that it's on, and it's more related to the focal length. Or the focal.
Yeah, I mean the two objects there. All you actually required to do that kind of demonstration is to have two objects in relation to each other, and one can move up, and the far one can move down. And you don't need that much of a focus shift. Sometimes you can have both of them in focus, but obviously one will be a little bit faint. But that's exactly what we see on the horizon, Bob. We see that faint thing being compressed exactly like it showed, and then going over the horizon. I just find that a little bit weird, and maybe we should investigate that more.
It's worth an investigation. However, Mount San Jacinto is sharply in focus, and so is the horizon. So Chicago here. Now there's some distortion in Chicago. It's being stretched vertically. But again, that's understandable with refraction. So that was my point. Thank you very much for letting me finish it up.
Okay, yeah, that's really great, and I thank both of you for being cordial thus far. We're going to get into audience questions, and we're going to start with a couple super chats, and then I'll read some that I've pulled out of the chat. Of course, super chats will get priority. Ilya Moon for $5 says, Bob, he's our man. He can prove the globe has no ether band. And I'm going to butcher this, Hervin Solo. This is a question for Stingray. How many times have you wiggled your independent variable today?
Many.
Haven't we all? All right, let's go to the chat. Here's another one from Ilya Moon. Ask Stingray what a pushytron is.
So a pushytron is, you call them gravitons, but you actually think that it's a fundamental, so it's actually what you call a virtual particle. It's the same thing, except rather than a pulling gravitation towards a mass, it's a pushing from a ether fabric space that exists everywhere.
Mm-hmm. Okay, another super chat, $5 from Johnny Regadu. Do blue water ocean navigators presume the world is a globe, or do they recognize it staking their lives on spherical navigation? Just curious.
You'd have to ask them. I'm not a navigator, but I would suspect that what they navigate on actually works, and it does work well. But that doesn't mean that it's a globe. It means it's evidence towards a globe, yes, but it's non-conclusive. There may be ways to make that work on a flat Earth.
I actually go ahead.
There may be ways to make that work on a flat Earth. You have to show those ways and show that that's the way it's happening.
2,000 years, Bob. 2,000 years, Bob. We'll be there in 2,000 years.
I am a navigator, and I navigate on a spherical Earth, and it gets me, and the numbers I come up with are correct. So that's pretty good proof right there.
Yeah, and I was a blue water naval officer, but I am staying neutral in this venue, so I'm going to stay out of it. Question from CatSlave56 for Stingray. Were you born this stupid, or did you take lessons?
We we don't take lessons, no, but we're just taught to critically think, and I apologize if critically thinking endangers your religion somehow, but that's just the way the world is. Thank you.
And thank you. Alexis Wood asks, no one in particular, what is the shape of the flat Earth?
We don't know the extents of the shape at the outer boundary. We just know that it's observably flat and motionless.
My answer to that is it can be any shape that you wish. Your fantasies are your own, and you can shape them any way you want.
Did you say you can shape it or you can shake it any way you want?
Yes.
Quake. Question for Stingray from Fred. How does our perspective of the moon face and shape not change no matter your position on the Earth?
That is under the same toroidal light influence that I showed on the sun. So we would see pretty much the same thing. We see that same face. But we see it at different angles, and we don't exactly see the same face as well, so the question is a little bit wrong. We do see a little bit of, I think it's about something like 2 to 3% deviation, but that can also be explained by toroidal fields causing the light to bend, since bendy light is the explanation for a lot of things on the globe.
Okay. I'm scrolling through. Let's see. Anybody else who has questions, get them in here. Let's see. Now, Liz D says, now we have to shake pushytrons out of our fabrics? Question mark.
You don't have to shake them. They can pass straight through your fabrics. It's fine.
Johnny Regadu says, what the heck is the reason for imagining all this stuff? I'm not sure to whom that was directed.
Obviously, Bob.
Seemed like a nice thing to do at the time. It was a slow day.
Yeah. We're all quarantined here. So, well, this was another question that's already been answered. What is a pushytron? We've already been through that. Okay, Gary W. says, can he explain how the Earth's magnetic field is generated, if not because of its spinning metallic cores, or is it just there?
I know that you have a hypothesis that you can't exactly verify. I know we understand currents and eddy fields very well. We've not yet fully, and again, this comes down to resource and time. You know, give us the money, give us 2,000 years, and I'm sure we can come up with just as valid excuses as the globe Earth.
You know,
Johnny Regadu. Well, go ahead, Bob.
One thing that I do want to just ask Stingray real quick. Do you have the same 2,000 years that we have, or did you just suddenly appear and didn't have the benefit of 2,000 years to do this as we did?
No, that's a fantastic question, Bob. And I believe that the human race has steadily, slowly started waking up. Some people call it woke up, whatever. But we're just getting more in tune with our environment. Our brains are becoming more active. I don't know why this is, but now we're seeing a kind of resurgence in critical thinking at this point in time over the last, let's say, 7 years. So armed now with the magic tools that we've got, like the P1000, we can go out there and do things that they couldn't do previously. And it's because of that now, that critical thought, that awakening, that you know, we've started doing this. And again, yes, it's a shame we didn't have the P1000 back 2,000 years ago, but you know, back then, just like it is today, information was tightly controlled. But today we have YouTube, and people can quite openly share ideas, and we can test and validate them. So there you go.
Cool. What have you done for the last 2,000 years? I mean, were you any place in particular, or were you somewhere else?
No, Bob. I'm not that old. But if you're referring to, like I say, the human race has been quite dormant throughout that time. We didn't have the technology to suddenly start questioning, the NASA lies or anything like that. Whereas today, we can do that with technology and awareness. And it's individual awareness that has brought us to this state. You can quite clearly see that all the flat Earth proponents are kind of the pinnacles in their field. My field is enterprise software development, augmented reality, virtual reality, visual effects, vision neural networks, machine learning, and mobile development. So you can see that we are an elite in terms of our awareness, knowledge, and our acceptance of technology and using these things in critical thought. We all are. Look at Anthony, Oakley, QE. So it's we just are.
So in other words, it was a time management issue. You had other things to do for the last 2,000 years?
Yeah, pretty much.
Okay, I understand that.
Okay. Next question, again from Johnny Ragadoo. What is the spin of a positron? I think by that he means on a quantum level, quantum spin, like a up spin, down spin of a quark or whatever.
Oh, we haven't got to that level yet. This is just a hypothesis. Like Bob says, I'm very open to testing it, and this is what we're working on. Our brightest minds right now, but it's incredibly hard with the limited resources and individuals that we have available, including limited time and money. But look out for answers in the near future.
I'm sure that Quantum Eraser is at a whiteboard right now, toiling away. From Theo Fun Guy, not a question, but just a statement that we need to name a train Pushytron, and I think it would be better named for a bulldozer Pushytron. Let's see.
That's it. I'm changing my account. I'm no longer Boolinator. I'm Pushytron.
Pushytron. It sounds kind of like a dance too. We could name a dance the Pushytron.
This is going to catch on. I'm telling you guys, it really is. It's going to take the world by storm.
Okay, from Walter. Sucking force of vacuum or pushing force of shadow? I'm not sure what that question means, but give a stab at it.
I think he's still thinking in gravitational attraction, much like graviton theory and mass attracting mass, and then trying to equate it to, but it's not. Mass is shadowing omnidirectional positrons emitted from the fabric of what you postulate as space-time, but it's emitting these particles in every direction and it's never ending. And it's the shade between masses that have less of the positron direction force, which causes the attraction between apparent attraction between two masses. So it's still mass dependent, but you have to think about it in a different paradigm, and it does conform to the 9.8 meters per second, and it is mass dependent. So yes, it works.
Bob, you got anything before I go to the next one?
No, I'm in awe of the intellect here.
Kip Granger asks, what holds the water in at the edges?
I personally don't know that. I mean, an honest flat earther like myself, I have to say I don't know. I've not seen it. I've not seen the edge at all. I don't even know whether there is an edge, to be honest. A lot of people say, how high is the dome? I've not seen the dome either. I don't know if there is a dome. There could be. There may not be. I just don't know.
Okay. Luke Filewalker. Why does a positron field... What? Why does a positron field would have a shape in the first place? I guess he's asking what is the shape of a positron field?
It's the inverse of a gravitational field. But like I say, you're trying to equate it to a gravitational field that is around a mass, and that's not it. The diagram that I showed shows a shade area, and a very good thing to look at is this isn't the first time someone's come up with this theory, by the way. I'm not going to give you the name of it because we like to allow people to do the research, as we say. But there are actual theories with different names. They don't call them, they're not as cool as calling them pushytrons. But there are theories that exactly hypothesize this mechanism that you can go look at.
All right. Quitties the Sprinkler wants to know, is Australia full of upside downytrons?
No, Australia is full of just every type of animal that wants to kill you. And I've got to go there in a couple of months. And I don't like crocodiles, spiders, or anything like that. So,
You know, I've got a question.
uh-oh.
If there are pushytrons, would we not be crushed? Because things were pushing us from all sides, pushing upon us from all sides.
It's a weak force, Bob. It's a weak force. It doesn't go on forever.
Okay, if we're in a pushytron shadow right now, why am I not levitating?
You're thinking about it as gravity again, Bob. We're in a pushytron shadow, which is the ground. The ground is the shadow. Therefore, the pushytrons that are being emitted inside the ground are hitting what you would, well, what you call atomic mass, which is preventing that from pushing me upwards as much as the mass amount of space above me that's pushing me down.
Okay, so if I open an umbrella, could I float like Mary Poppins?
No, again, because there's more pushytrons hitting the top of that umbrella and going through it and causing the atomic mass to have a downward apparent force than there is coming up, because the ground beneath you is shielding the upward pushytrons.
Gotcha. All right. Well, that makes sense.
Excellent. Yeah, well, Bob, the bottom line is we're living in a pushytron world, and I am a pushytron girl.
I knew that was going there.
I was waiting for it.
Mobile Gamer 2020 wants to know if Pushytrons is Megatron's brother.
Could be. I'm a fan of Megatron.
No, it's his older sister. It's Karen Pushytron.
I guess this is in reference to one of the pictures that we were looking at earlier. Jose JG wants to know, isn't that a mirage? How much refraction 7/6R? I think that's a dated question. I'm not sure which picture we were looking at when that came up.
Talking about Chicago, I think. Yes, it is a mirage, but you can also predict it.
Kip Granger wants to know, why do I keep thinking about Ava Max during this debate? I don't know who Ava Max is.
And now I'm breaking out Google.
Be careful.
She's an American singer-songwriter.
Let's see.
Jolene. Well done. Well done.
Yeah. Someone asked, you invoked the name of Riley, and they're asking, are you talking about the same Riley who won DFOTY? That's Josh Wilson who asked that.
Yeah, well, all I can answer to that is, you know, you're doing something right when you garner attention and ridicule. That's been the kind of pattern throughout history a lot of the times. Look at the ancient Greeks when they even proposed your stupid model.
Well, you know, just remember, and I'm with Stingray on this one. The pioneers, you can always tell them they're the ones with the arrows in their back.
Yeah. Theo Fungi wants to know if we can have a debate with Stingray versus Stingray.
Yes, I would win.
Ilya Moon wants to know, which one of you took all my pushytrons and pulleytrons?
No such thing as a polytron.
I think maybe her batteries just went dead. Okay, we're running out of questions, people. If you got some more, then throw them in there. Robert Kozlow, how do pushytrons relate to gravitrons?
They don't. They are a superseded mechanism by which you see apparent movement of objects due to
Everybody take a drink.
Yeah.
You said superseded. That was the $64,000 question.
Okay, Tim Garak wants to set the record straight. He says that DFOTY stands for Distinguished Fellow of the Year. Something we should all strive for. Mr. Gadget says that I missed his super chat. I did I? Put it in the regular chat and I'll read it out.
You missed Jolene's super chat. For
Oh, did I?
$5, Jolene has secured the website pushytron.com and pointed it to Schrodinger's channel.
Oh, I did miss Mr. Gadget.
Well done, Jolene. Epic.
Mr. Gadget, also known affectionately to most of us as Carlos. How does GPS work on flat Earth Doppler shift?
We're still looking into that, Carlos. But there's some interesting technology coming out, Carlos, and I'll let you know. So, for instance, 5th generation networks, or 5G as you call it, or indeed Wi-Fi 6 for home routers on at least 3 or 4 routers now, do what you call beamforming. And beamforming is black magic of antenna arrays that allow you to actually create a higher magnitude signal at a local point. So I don't know is the answer at the moment. Is it possible that there is some mechanism at play to create a direction-based kind of signal from an antenna array? Then absolutely yes, because we're using it for 5G right now. And I've even got a home router that does exactly the same thing.
Huh?
Beamforming, Bob, look it up.
I'll do my own research.
Just to explain that more, beamforming is about offsetting the timing of signals and frequencies slightly to allow it to get a higher a higher magnitude in a local area, and that's how 5th generation networks use multiple antennas, because they don't have a strong enough signal, because it's millimeter wave. The attenuation on that is absolutely ridiculous. So they had to invent this technology, and that same technology, which will have been around a lot longer than its application in today's environment, could be responsible for directional signals which you think are coming from space. Thank you, Carlos.
All right. Giles Gosselin says, so what is the best flat Earth skill? Sounding confident?
I'd say it's critical thinking. I think the human race has lost the ability to critical think and question things, and that's what flat Earth brings you. It brings you almost instantaneous fame and money, along with being at the head of a very elite group, and allows you to, it brings you the best skill. Absolutely, critical thinking. There you go.
Okay. Johnny Regatu, why don't we get lighter when the moon sails overhead?
We actually do. Read your own model.
Okay.
How do you think tides work?
Unfortunately, I must concur with my flat Earth colleague.
And how do you think tides work is my question back to you. So there you go, yes.
Exactly.
Theo Fungi, may have already read this one, I'm not sure. If we go to the top of Ben Nevis, whatever that is, would you float up?
And again, this is the critical problem with Globers. You lack the ability to think in a different paradigm. You are stuck to this mass attracting mass and thinking that somehow we'd float. That is not the case. The shade portion of a mass, because the atomic mass of the matter is slowing the positrons, is causing the positrons with no occlusion above to freely flow onto you. It acts and presents exactly as you describe gravity to the T. There is no difference in the effect.
The Factard wants to know, does the positron shadow create a warmer or colder temperature?
That's a very interesting question. And we don't know, I'm going to say, if I'm being honest.
Okay. Before I forget, tonight at 10 o'clock Eastern Standard Time, I will be on Sit Down with Debunkers. Great show, sort of a new show. Everybody get over there and subscribe and watch. We'll be talking about sorts of all kinds of conspiracy things tonight. Going to be a good time. G1 Soundwave. Wait. How does he know they are pushytrons and not pulleytrons? Good question.
Well, I'm from the frame of mind that you can never truly know anything. You only have and much like all flat earthers, we don't know things. There's high probability and low probability, and there's every which metric in between. So, do I know? No. Do I suspect? Yes. Does it fit the current model? Yes. And it's just an illustration of, you could be closed-minded and think gravity pulls, mass-dependent, or you can admit that positrons from a ether fabric also fit exactly the same and cause exactly the same effect. It's just about opening your mind, and that's what you get as a flat earther.
Okay. Walter is asking, is helium made of positrons?
Sorry, say that again. Is what?
Is helium made of positrons?
No, and again, this is, I absolutely don't get this. I'm going to have to share this again, because this is exactly one of my opening points. My opening point is everybody has a closed mind, and this is what science dictation gives you. Because I'll be the first to admit, I've said I'm a software engineer. I know machine learning, visual neural networks. I do not know physics, and I'm not a mathematician. But because I am a flat earther, I have an open mind, which means these two masses here, the atomic masses, the atomic mass of these two objects, shade. We've got positrons being fired. Let me get rid of this. Being fired in this fabric, this ether fabric, all around in every single direction. It's hitting every part of this object, except we've got a problem. The ones coming from the right are being shaded and caught by this mass. And it's being shaded in the center here and not hitting the right-hand side of this brass ball. So iron ball, brass ball. Which means this shade area, there is less force on either inside edges, inside surface area of these two balls, which cause them to come together, because the positrons from each of the extents, the sides, are hitting this mass and pushing, and the ones from here are hitting this mass and pushing, but they're shading each other, which causes a lack of push from the inside. Otherwise, there'd be equilibrium. So then they apparently come together. It's no difference to what you call gravitational fields and attraction based on mass.
Hey, Stingray, I've got a very interesting question from a much smarter person than me in the chat named Jose Reyes.
Okay.
The question for you is this: Why is it? What is the effect of pushytrons at the poles versus the equator? Is there an effect of latitude on pushytrons?
That is an excellent question.
That's a fantastic and well-reasoned question. I can't wait to hear your answer.
It is. It's quite interesting, and like I say, it's atomic mass relative. So it could be that due to, and just so that we're all aware, the natural form out of particulate chaos is disks. We all should know this. It's why Saturn has rings. It's why our galaxies are disks. This is just what occurs. Now, what can also occur, just like on Saturn's rings, is we can have differences in masses due to the pushytrons that are being, so exactly the same way that we have gravitation, or your supposed moons on Saturn's rings come together and actually form, it's actually the clumping of those moons that form the rings. We can have uneven distribution of mass within a disk quite easily, which could easily explain a slight difference in the pushytron effect around the equator.
Well, actually, I would like to join you on this because I actually believe I have an explanation. And that is that at the North Pole, the flat Earth disk would have to be thickest, and it would be thinnest at the equator, and then it would thicken again at the ice ring. So the underside of the flat Earth would be spherical and lens-shaped to block the pushytrons at the poles more than the pushytrons at the equator are blocked.
Good point, Bob. And all I'll just conclude is we've only ever drilled 9 miles down, so we can't really verify this. So it's all speculation at this point.
Okay.
But it's a valid hypothesis.
Indeed.
Christ Puncher says that he has the song Jolene stuck in his head, and I can concur with that. So do I.
As you rightly should. Hashtag Jolene is epic.
Yeah, it was a great song. I keep losing my spot here trying to find questions. Damn it. John Rapp says I missed a couple super chats. I'm terrible at this.
Puncher, pushytrons are a special time in a boy's life. There are magazines devoted to that.
Oh, back in our day, Bob, I mean, we were stuck with the Sears catalog lingerie section.
National Geographic. They
You're giving up all of our secrets. Oh, okay, TP Seeker. Would a pushytron be able to create a black hole if given enough power?
Black holes are highly theoretical. We can see effects of the thing is we don't know that black holes exist. We don't know that space is out there. You see effects. We've not gone up to it. We've not measured it with a stick or anything. So I just don't know, and neither does anybody else really.
Oh, question for Bob. God, I'm going to butcher this name too. Andreas Eid, I guess. Question for Bob. Why is NASA, with their budget, stupid enough to forget showing cities on pictures from the ISS at day, but they show them at night?
Well, the government has basic incompetence, so they didn't Photoshop it in on the day pictures, and somebody reminded them to do it at night.
Sounds legit.
Works for me. And by the way, Jose is trying to push this again. He keeps trying to debunk your pushytrons, and he's got another one. Why is it that pushytrons seem to change whether you're flying east or west?
That we don't know yet. We'd have to look into it, I'm afraid. I mean, like I say, it comes down to resource, money, and time. If you comparatively relate the two opposing, equally valid theories, then there's a little bit of bias in manpower, time, and money. But we're getting there.
But what would two opposingly valid theories be? We have the Outfos effect, of course, on a spherical rotating Earth. But what would what would account for that effect with pushytrons on a flat and stationary Earth? Would it be the lensing underneath the ground in places that we can't?
Well, no, it could be. It could be a number of things. We haven't really determined the exact nature of pushytrons, other than postulate that they exist. There
Could you
could
name
be
one for me?
No, not yet. Sorry, Bob. It's cutting edge. Like I say, all the people at the moment that are in the flat Earth community are leading cutting edge in their field, which unfortunately means we've got to wait. We'll have to wait and see.
Well, is there a chance that that could be compartmentalized within the flat Earth community, and they're withholding that from you?
I doubt it, because the flat Earth community, unlike modern day science, is very open, sharing, and inclusive, and we take care of our own, and we're all such nice, non-argumentative, intellectual people. So no, I don't think so.
Well, most of the flat earthers that I run into, of course, are just pillars of maturity.
I would agree.
So
I would agree.
tend to agree with you. Yes,
Indeed.
upright, ideal citizens.
I think we can all agree with that. Zanju asks, please ask how pushytrons are generated and how they don't violate the conservation of energy.
We don't, the same way that we, it's the same kind of theory as your space-time theory. There is no definitive path to walk back onto as to why, what is this and what is the exact cause. There isn't. There's just the known effects and predictions that can be made from it. So unfortunately, an honest answer is I don't know, but then an equally honest answer is neither do you.
Okay. Zanju also asks, wouldn't each of those objects emit pushytrons against each other? I'm not
The
sure
answer
which
is
objects.
no. Well, yeah, he's on about the two balls, and the answer is no. Mass does not emit pushytrons. This is not gravity. This is not magical mass creating an attracting force or having a gravitational field. This is a field or a fabric everywhere emitting omnidirectional force, and mass creates shadows, and that is it.
Okay. Tesla Ranger says, is it why Saturn is a sphere? I don't know what that means, really.
Well, unfortunately, Saturn's a light in the sky. I was just going with your theory for a short amount of time.
All right. Roscoe P. Coltrane says, are the other planets flat too?
We don't know that. We haven't gone up to them. They appear to be just lights in the sky at the moment. We can't tell their size or their distance. We can't tell very much at all, but we don't look to the sky really to try and work out the shape of the Earth that we're on.
Okay. Robert Coslow says, what is the math that shows pushytrons?
I'll tell you what, I will disclose that. I don't have the link to hand, but I will actually put forward the equations for it or point you to it. I would direct you, in fact, no, I'll direct you later. I'll put it in as a comment on this video.
I hear a Jose.
Yeah, that was That was an uninvited Jose.
Did I accidentally let him in? Because I was denying him entry, actually.
Yeah, I'm not sure how that happened.
Well, Jose, you're a dick. Quit it. Just saying.
Stroke Assaulter says, what is the mathematical formula that demonstrates a pushytron?
Like I say, I will actually post, and I promise you, unlike the lesser tier of flat earthers that sometimes you see, I will actually post the link explaining this theory after the show.
All right. Liz D says, Saturn is a light in the sky, question mark. Does he not believe in telescopes now?
I absolutely believe in telescopes, and that telescopes work by refracting light through multiple lens elements off a mirror and hitting your eye. Thus, you are seeing light. I absolutely believe in telescopes. Thank you.
Okay. Professor Phil Bell, who will be a guest on this channel 1 week from today, says, Stingray, you forgot smell has both an attractive and repulsive force.
Nice.
Cannot argue with Dr. Bell. Let's see what else we got here. A couple people are saying that I missed some super chats. Is there a way for me to go somewhere that just lists all the super chats by themselves? Does anybody know?
Yeah. You could
Should
go
be on the main screen.
right. There might be an advanced button you might have to go to on the stream screen. I'm not exactly sure where they moved it to in studio, but there's a way to see it for that stream only.
Okay, let me see if I can do that real fast because I definitely don't want to miss super chats. Let's see, go to my YouTube studio here.
While you're doing that, I'll just present my camera again because I can't stop playing with this. This is pretty decent.
Unfortunately, I will not be showing your camera on screen anymore because I have to actually prevent the link from going out again. I mean, anybody could technically go back and find it anyway, but just to make it harder on them.
Ah, okay.
Okay, let me see if I can figure this out.
And yes, it was my mistake for allowing them to see the link at the top of the screen.
Okay, no, I do not know how exactly to see just super chats. So if anybody did super chat and I missed it, then just type it in and we'll get to it as we wrap up here. I'm trying to get back to the regular chat now.
So I take it that you've got Professor Phil Bell coming on here, and an open invitation for some of our best minds to challenge in, like Quantum Eraser, for instance, could come on.
Yes, what we're going to do is I'm going to have Dr. Bell on, and I'm just going to chat with him some things that I think are interesting. You know, how he got into this motley crew of us, and what motivates him to stay around here and deal with our nonsense. And then we'll take some legit questions from the chat, and the link will be available to any flat earther who wants to come in and thinks he can go toe-to-toe with Dr. Bell, which I don't recommend, but we've seen them do it before.
Oh, I'm sure
Okay.
QE. I'm sure QE could tear Professor Bell apart completely if he came on.
Yeah, QE sent me a message a couple of months ago and told me that he had a surprise for me and to watch out because there was a surprise coming. and I haven't heard anything from him since. So I'm sure it's in the mail. It'll probably be here any time now.
You know, I
Okay.
concur with Stingray. I think QE would really do well against Dr. Bell. QE is just so smart. So smart. I think he'd tear Dr. Bell a new one.
He is the gold star in the cap of the flat Earth. Crow XE says for Stingray, the globe can't make predictions about the sun like FE. Hold on. Yeah, the globe can't make predictions about the sun like FE now. It was one man about 20 years ago who made it happen using humble tools. That's Kepler. Where's the FE Kepler? I don't know if I read that wrong, but I think he's asking where's the flat Earth Kepler.
Yeah, unfortunately, that is the sleeping warrior, which we call QE, who's yet to kind of come out and really take charge of all this stuff. And hopefully we'll start by coming on and showing how much he knows over Professor Phil Bell.
There you go. So he's got a week to prepare. Alexis Wood, where do meteorites come from?
All we know basically is they up. They come from up, but we don't know what's up there.
Professor Phil Bell again asserts planets are flat. They appear round because of the way they are spun. Sounds legit. Andreas Eid. I'm sorry, I'm saying your last name probably wrong. Pushytrons spin at 1,000 miles per hour from west to east. That's an assertion. I saw a super chat pop up. Okay, for 229, is that pounds or is that euros?
That's euros. It's euros.
Okay. Does a sextant work on a flat Earth? I think that's for Stingray.
Well, if a sextant works and we're on a flat Earth, the answer is quite obviously yes.
I have a question for Stingray.
It better not be on sextants.
Oh, no. What do I know about sextants? I'm just curious, is there a pushytron wind or a pushytron drag that perhaps we could measure with an interferometer?
There could well be, but again, we've not really looked into this yet. And if you're talking about the readings that you get from a fiber optic gyroscope, then yes. There could actually be such a thing that's generated by the field of the land mass that we're on that actually does direct them slightly, but it's unconfirmed. It may be the effect of Bob's 15 degree per hour reading. We don't know yet though. Is the honest answer.
John Rapp super chatted. Bob, admit it. You sub to Stingray Truth Channel, don't you?
Well, if I don't, I'm going to make sure I do because he's got some good stuff.
Bad Chad super chatted. Ask him if he's so smart, then why does he look dumb? I'm not sure to whom that is.
It's definitely to Bob.
Yeah, I think that's probably genetics.
Happens to the best of us.
No one's ever seen what I look like, so it has to be to Bob. That's basic inference.
Yeah.
John Rapp super chatted again. Water tastes flat. Trust your senses. I think we're at the end of questions. Unless someone wants to put any in, we'll start to do a wrap up.
Schrodinger's Cat Channel and hashtag FreeJoseJG. Stop abusing the wrench. Don't do that, guys.
Yeah, can you take care of that, Bull? Thank you. Okay, Professor Phil Bell says, I love pushytrons. They even explain magnetism. Well done, Stingray.
Well, like I say, it's one of our greatest philosophers that came up with this, that allowed us to develop this theory, and that's Dell, Beyond the Imaginary Curve, who quite, quite articulate, realized that when you pulling on a rope, you're not actually pulling, you're pushing. And when you're pulling a door open, you're not exactly pulling a door open, you're pushing it, because your hand goes to the other side and pushes it towards you. And it's that kind of new age thinking, that critical thought, that we so desperately need as a human civilization.
Okay. Bruce Baker did a $5 super chat, but no message. So if you have a message, type it in and we'll read it out. Question from Jose Reyes. Why are satellite dishes pointed at the sky?
Beamforming. Go look it up. It's a wonderful transverse electromagnetic wave theory combined with just all kinds of dark magic. It's lovely, and they've had it for years.
Medicated GT, are water balloons flat?
I don't know.
Stroke Assaulter. So if a pushytron cannot be scientifically demonstrated, how can you even confirm they exist?
That's an excellent question, and I would point him to space-time. Same deal.
Giles Gosselin, how do seasons work on a flat Earth?
Seasonally, obviously. Something that you recorded over time, and it's obvious. Most of the flat Earth is obvious, so there you go.
All right, let's see if we got any more. Okay, do you guys want to each do a 5-minute wrap up, and then if any more questions come in, we'll address those after that.
I'll go first actually this time, if you don't mind, Bob. So, I'd like to say to everybody in this community, there's no need for animosity, there's no need for shouting, there's no need for swearing. And quite literally, the person in the room shouting the loudest and swearing is most often the one that is wrong. So that's not something that we need in this community. But what we do need in this community is very calm, very collected, flat earthers that have critical thinking ability. And we need to push the known science, which is what we're all doing collectively. And like I say, the heads in our fields, I mean, the Riley egg experiment just is absolutely cutting edge. There's hardly any equal. So we need to keep doing what we're doing to push this forward. And I know some say that this is a terrible conspiracy created by governments to separate stupid people from the rest of civilization, so that they can be pushed to the side. But no, we're going to bring them back into the flat Earth community, even though they are pushed to the side. And I would just say to everybody out there, we can be cordial, we can have a good discussion, we don't need to shout, we don't need to go spazzy. Shout out Brian's Logic, Brian Leakey, and probably every other Brian out there. And we can take the fight to the Globers in a civil manner. Thank you. I yield the rest of my time.
And Bob?
Well, I have to say that is probably one of the more interesting debates that I've ever participated in. I learned a lot. I gained a new respect for Mr. Stingray as a flat Earth scholar. And I've got many things that I need to research from now, and I want to leave you all with this wonderful photograph I took last night. You see the Big Dipper asterism in Ursa Major, and then below it, near the horizon, you see the comet Neowise from Marquette, Michigan. Thank you very much for having me, and it's been a very enjoyable discussion.
Excellent. Thank you, Bob, and thank you both for being here. Let's clean up with the last couple of super chats that we have. John Rapp says, pulling is just assisting the Pushytron shadowing. Tay's auditors laugh like hell, which is an excellent channel name, and I agree with the sentiment. If the earth was flat, skateboarders would be grinding on the edge. They most likely would. Another one, $5 from Bruce Baker. I have been an airline pilot for 40 years, did countless North Pole crossings safely. How if the earth is flat, respectfully? I think that's a question for you, Stingray, if you want to answer one last question.
Well, yeah. While flying, did you ever have to point your nose down? No, it's not a thing. On the flat Earth model, you can fly across the North Pole. It's really simple to do so.
Okay. And for Bob, Fred Bailey wants to know if you will rage quit. Which
You're all
would
a
be
bunch
hilarious.
of assholes.
And Bob is gone. So I think we can safely say that Stingray won this debate hands down. I, for one, am converted. I don't think there's much else. Do you want to say anything else, Stingray, before you drop the mic and walk away?
Do you want me to come clean now that we're done with this exercise?
Yeah, we may as well.
Okay, so the way to invalidate pushytrons is really simple. It comes from Lesage's theory of gravitation, which actually was put forward and postulated as being an active replacement. The equations still hold true, but the thing that invalidates it is thermo.
La la land. Now you got the chance to remove me. Do it. Do it now. La la la.
The thing that invalidates it is thermodynamics. When you start calculating the forces of these virtual particles exerting force on the mass, the heat generated would mean that everything bursts into flames instantly and is incinerated. That's the way to it. But it was actually, look it up for people, Lesage's theory of push. And it's an interesting read. But yes, yeah, flat Earth is ridiculous.
Yeah, this was great. This was an idea that I came up with partially because both you had said that you could be better flat earthers than a flat earther, and I think we've borne that out tonight. It was really interesting to see someone try to actually make legit arguments for flat Earth rather than all the debates that I participated in where the flat earther just says, nuh-uh. And this is something I want to do in the future for all of the flat earth debunkers out there. Each gets a try at being a flat earther and debate somebody from the globe side. I think in the end, it'll make you a better debunker. And it clearly entertained people. We had 130 some odd people watching at one point.
I like the idea, Schrodinger's, of, and I put this forward once upon a time. I said, get to planet Earthers. I don't like the term ballers. The magnitude of that is just so stupid. And then get 2 flat Earthers and get them to argue opposing positions as a team. So the flat earthers argue for the heliocentric globe model, and the globe argues for the flat Earth. And that, throughout my career, I've always determined how well someone knows something in my fields by how much they know about what doesn't work or what they're critical of. And it's the same kind of thing. If you put 2 opposing teams and get them to steelman each other's position, you get to know you know, the critical thought of one versus the other. And I'm pretty sure that most of the time, the actual flat Earth team will lose when they're arguing for anything, even for something as demonstrable like planet Earth.
Right, because most of the flat earthers that I've talked to, and I'm sure Bob can weigh in on this as well, that they don't know the model that they're arguing against.
Well, I've got to admit something here, and that is that I do know the model, and I do know the flat Earth model, or at least what they call the flat Earth model. But Stingray actually did a very fine job with this one here, and he caught me with things that I wasn't aware of. You know, these pushytrons. You know, the idea behind a pushytron almost makes sense. And with more physics knowledge, you'd bring in the second law of thermodynamics and the implications that pushytrons would have on the second law of thermodynamics. And he pretty much exceeded my ability to do that. So that was a very challenging debate. Yeah,
Stingray, you really nailed it. I was wondering how this was going to go. This whole concept that I had of two debunkers debating each other, and I was a little nervous at first, but you really nailed it. And we've got two more super chats. Taze Auditors Laugh Like Hell for $2 says, "Are all planets flat or just Earth?" I guess that's a moot point now since we've let the cat out of the bag. And John Rapp, again for $2, says, "Well done, Stingray and Bob. Thanks, Schrodinger's cat." And thank you, John Rapp. So yeah, I guess
I was, in all honesty, Schrodinger's, I was actually a little bit concerned because taking an opposite position and then trying to find the one thing that I didn't want to do. I actually asked a few planet Earthers, Globers, and even I asked at the start of this conversation, should I be allowed to lie? And one of the things that I wanted to do was claim I have enough authority in visual effects and 3D graphics to be able to point at the moon landings and say, hey, they're fake. But that's actually dishonest. And a lot of times people say, oh, flat earthers are outwardly dishonest. And I did think early on, well, could I act that way? Could I just come up with this assertion? And it wasn't until the start that I thought, no, I can't actually do that. It's not the right thing to do. I just have to show like these practical demonstrations and the possibilities of what if, or just even outside the box thinking. And I did actually invent pushytrons, but not the theory of a pushing force. And that was one of the ways. But I did, when researching it, figure out that you could invalidate it quite easy with thermodynamics. But the thing about the focal plane shift in the focus point shift in a camera lens, I was a little bit dishonest there. I said it can scale. No, it can't. The only way that can ever work is on the scale that I showed you it, because it's about a focal point shift inside the lens, which is about 9 millimeters. I think when I was doing it, it was about in between 1 point. It was about 9 millimeters. We're going to say about 1.1 centimeters or something, but about 9 millimeters to 1.1. And that does not scale up. That will only ever affect a 10 centimeter range. And it doesn't matter how big I make the observation. So I was a little bit dishonest. I did go against that a little bit, but thank you very much for the opportunity. I did enjoy it. And thank you, Bob, for not being as perhaps confrontational on some of the points as you could have been.
Wasn't here to do that, but the bottom line is that was a great demonstration, and that is something, as you said, Lemon likes to talk about. I know that it's not right. I know that it doesn't work, and that would be a great thing to look into a little further. And the fact that it only works over 3 inches, 4 inches, that does make a big difference there. That's very interesting.
Just really quickly as well, if you don't mind me, because you're involved in this as well, Schrodinger's, is just mention B-Ball's Hawaii, because you're in Hawaii at the moment and he's based in Hawaii, doing observations across Pearl Harbor, across to the main built-up city area, and doing it day in, day out. And I'm actually going to model I'm not going to bring any predictions to it, and I'm going to use very little math. All I'm going to do is I'm going to build that complete elevation profile and topology of that area from where B-ball is stood, taking multiple observations every day in, day out, looking across the water to buildings 22 kilometers away. And I'm sorry I use kilometers and not miles and cm versus inches. It's just me. And I'm going to build a flat model and then introduce vacuum, standard atmospheric refraction, medium refraction, high refraction, and calculated refraction for the day based on temperature profiles, exactly what Bob pointed out with the temperature of the ocean and the temperatures in the air at different elevations to work out a light profile that is going to work. And I'm also going to compare it to a 1 degree curvature over 69 miles or 60 nautical miles for Schrodinger's, with vacuum, medium, standard, and high, along with the refraction for the day, and do nothing except on all of these days compare them to the expected result. So comparing an apple to an apple, basically. And I hope to be able to do that with a few other examples. If anybody's got any examples that they would like me to model to match up with their observations, if they've got multiple observations, I'm all for doing that.
Yeah, so I am here in Hawaii for several weeks, and right now I'm on quarantine for about another week or so. And I have talked to B-Ball for Life. I'm going to be getting with him out at his observation site. And I'll be taking my Mavic Mini drone out and getting some footage along with my Nikon camera. And I'll be hooking up with him, and we'll send all that over to you and see what we can get done with that. With that, let me plug one more time that here in about 2 hours or so, I'm going to be on the channel Sit Down with the Bunkers for their evening show. So if you're here, make sure that you get over there. Any last words, Bob or Stingray?
No. Stay safe in this challenging time, and peace to everyone. There you go.
Thank you all for coming and visiting with Schrodinger's and Stingray and I. I had a lot of fun doing this. I think everybody involved did. Yeah, just to clarify things out in the chat, no, Stingray is not a flat earther. Stingray and I can both be better flat earthers than the entire flat earth community put together, and this was an exercise in a debate doing just that, and quite frankly, Stingray lost the coin toss.
Yeah, I think we should reverse it here in a couple weeks and try to do it again the other way. Give you your turn in the barrel there, Bob. We got one last super chat from Bruce Baker for $5. Great chat. Sure had me going. However, I wouldn't recommend. Shit, it scrolled on me. I wouldn't recommend taking that position at work if your job requires drug testing. Yeah, indeed. And also, let's thank Bullionator Dave for producing the show. And I apologize for the unwanted guest that you shouldn't have had to deal with, and that I'm not going to give any more of my time or energy. Well,
I have to apologize for him getting in the first place, because it's my fault he was able to do that, and it was just an oversight on my part. It's kind of one of those things that you don't run into so much anymore because Google Hangouts went away, but basically that he's practicing the old technique of sniping, and it's really stupid because I'm not going to show him, and I was denying him. I must have admitted him by accident one time when he was trying to get it in. So just note, don't give the link out. Don't give the link out. Don't show the link on screen because it's bad.
Yeah, and I'm not going to give that topic any more oxygen than it already has. One last super chat for $10 from Carolyn Clark says, "For your good work." Thank you, ma'am. And with that, I guess we are out.